In this video, we're going to talk about spread, like how spread out is your data. It's also called variation. How much does your data vary? Imagine we have like a classroom full of students and I ask you all to spread out as much as possible. You're all going to get really far away from each other. Or if I ask you to be less spread, you're all going to get really close together. So it's exactly what it sounds like. It's how far away from the center are you? Like how far apart is the data? For example, imagine that this plot here represents the speeds of cars on a road. Notice that they both have about the same center. So in the last video we talked about center. In both cases the center is at about 70 miles per hour, I assume that's what this is. But on this first one, you've got some really slow cars down here lower than 50 miles per hour and some really fast cars like up here at like 90, maybe even 100 miles per hour. Whereas on this bottom graph here, you only have data points that are pretty close to 70. I mean, it goes from about like 60 to maybe like 70 something, but it's all pretty close to the center. So this one is much more spread. It has a bigger variation or variability than this one does. So again, spread is just asking like how much is the data spread out? If the data is all clustered around the center, the spread's going to be a small number, and the further everything is from the center, it's going to be a bigger number for your spread. And there are a few different ways to represent spread, just like there are a few different ways to represent the center. So which of these two data sets do you think is a greater spread? That would be this one. This one goes from like 2 to 100, and it's kind of all over the place, whereas this one's all right around 9-ish. All right, so there are 4 ways to represent spread that we're going to talk about. There are actually more, but we're going to hit these 4. Range, which you've probably heard of before. Interquartile range, which you've also probably heard of before. Mean absolute deviation, which is sometimes called MAD, which you may not have heard of that one. And then standard deviation, which is actually an Algebra 2 thing, but we're going to go ahead and cover that now. Okay, so to start off with, a company is shooting a commercial and asks 2 different modeling agencies to send them a group of 5 models with an average age of 17. The company Modeling Marvels agency sent 5 models with these ages, and the company Acting Up Models Inc. sent 5 models with these ages. So first of all, did the company do what was asked of them? Did they send a group of 5 models with an average age of 17? The answer is yes. If you add these up and divide by 5, you do get 17. And if you add these up and divide by 5, you also get 17. But what is the difference between these 2 groups? And what is the problem with this group? The problem is they were probably asking for generally 17-year-olds, and this group sent children and also older people. So this group is more spread out. It has a bigger spread than this one does. These data points are further from the center at 17 than this one is. So that is exactly what spread is. So let's start with range. Range is like, what is the range of the data? What does it range from and to? So basically you just take the maximum number minus the min. That's it. So for example, on this one, on this one, the range was just 21 minus 15, which was the smallest, which is a range of 6. Basically, from the youngest person to the oldest person was just 6 years. On this one, the range was 40, the max, minus 3, the min, which is 37. So from the youngest to the oldest, it was a range of 37, which is much bigger than this range, which tells us this data is more spread out than this one. Let's also talk about interquartile range. So quartiles just means you split your data into quarters. Like, let's imagine this is all the data then this is going to be the lowest 25%, like the lowest numbers, like the first quarter of data goes right here, and then the next quarter of data, and then the next quarter of data, and then the top quarter of data. And so we call this point right here the first quartile, or sometimes, let's actually write it like this. We call it Q1 for the first quartile. And this is Q2.
Teacher, pardon the interruption, but if you could release all football players to the cafeteria, please. Thank you.
So we call this Q1, Q2, and Q3 because it's the third quartile. By the way, Q2 is actually just the median because it's the middle number at like 50% of the data kind of thing. Sometimes when you get test scores back on like standardized tests, they'll be like, you were at the 75th quartile or something like that, which would be like right here, meaning you scored higher than 75% of everybody. All right, so the interquartile range is basically the same as the range. You just do max minus the min, but with the quartiles. So you do Q3 minus Q1. This is actually on your formula sheet. It says the interquartile range, IR, is Q3 minus Q1. It even tells you in words as well. It's the difference between the first quartile and the third quartile of a set of data. So let's go ahead and try an example here. This is a pretty long data set. It's already in order for us, but if it wasn't, I would want to put it in order from lowest to highest. And then let's go ahead and find the middle point. To find IQR, I've got to find Q3 and then subtract Q1. It would help if I could find the middle of the data first. So I've got 1, 2, 3, 4, 5. Okay, so that right there is the median. I don't need that, but I'm just going to mark it. What I'm going to do to find Q1 and Q3 is basically just split the data in half. Since the median was right in the middle, I'm just not going to include it at all. So split the data in half. This is the lower 50% and this is the upper 50% of the data. To find Q1, you just find the median of this lower half. So basically what number's in the middle over here, and that would be 5. That's Q1. And what number is in the middle over here? That would be 18. So that's Q3. So that's Q1, Q2, and Q3. Basically, you just find the median of the lower half and the median of the upper half. And so now to find the interquartile range, I'll do 18, which was Q3, minus 5, which is 13. All right, now let's take a look at this data set. They look pretty evenly spread out, so it's probably going to have a similar interquartile range to this, but we'll see. So again, I'm going to find the middle first. Okay, this one actually has 2 in the middle, and the median would be 10 right here. If that's the case, just split the data right down the middle. So deal with this half separately, deal with this half separately. Q1 is going to again be the middle number over here, which is 7. And if there are ever 2 in the middle, you average them, just like you do with the median. And then the middle number over here is 16, so that's Q3. So my IQR, or interquartile range, is Q3 minus Q1. 16 minus 7, which is 9. So kind of close to this.
Lynn Morton, could you please come to the office or either call my extension?
So according to this one right here has a lower, it's less spread out than this one is because it has a smaller interquartile range than this one does. Also, just want to point out, we're going to make box and whisker plots eventually, and those come from the 5-number summary, which you basically just did. The 5-number summary is the minimum, Q1, Q2, Q3, and the maximum. So keep that in mind once we get to box and whisker plots. Yeah, there's a summary of that actually. So minimum, Q1, Q2, which is actually just the median, Q3, and the max. Let's actually do one example of that. So this data is not in order. I'll need to put it in order first. So 3, 3, 4, 5, 6, 7, 7. I already know the min, that's 3. Let's write it up here. The min is 3, the max is 7. Let's split it in half. 1, 2, 3, 4, 5, 6, 7. So this one is the median, or Q2. And then if I cut it in half, that's going to be Q1 because it's the middle of this lower half. And this is going to be Q3 because it's the middle of the second half. So notice these actually ended up being the same number as did these, and that's okay, that happens sometimes. So that's what we call the 5-number summary of a data set. All right, we're going to talk about one additional way to find how spread out a data set is, which is called the mean absolute deviation. I'm going to go through an example and then I'll show you the steps, but I think just seeing an example first is a good idea. So imagine you got this many likes on your past 6 pictures, which is not a whole lot. So the mean absolute deviation basically works like this. You find the mean, and then you figure out how far each of the data points are from the mean. So let's start by finding the mean. Add these up and divide by 6. That gives you the mean. Remember the mean? We use this X bar symbol to represent the mean. So I'm going to add those up. And then divide by 6, and I got 16. So that's the mean of this data set is 16. Just leave it on there. Next, what I'm going to do is take each of these points and see like how far is it from that 16. If I do 10 minus 16, I get negative 6. If I do 15 minus 16, I get negative 1. If I take this other 15 and subtract the 16, I get negative 1. If I take 17 minus 16, I get positive 1. 18 minus 16 is 2, and then 21 minus 16 is 5. Basically what this tells me is how far each of them are from the mean. Also, it doesn't matter if they're positive or negative, so what we do is we actually just take the absolute value of each of them just to make them positive. So the absolute value would be positive 6 and positive 1 and positive 1, and these just stay the same. So basically this is saying 10 is 6 units away from the mean, and this is 1 unit away from the mean, and this is 1 away from the mean, and this is also 1 away from the mean, and this is 2 away from the mean and 5 away from the mean. And then to finish this off, you just find the average of these. Basically, we're finding the average of how far away they are from the mean. So, add all these up and divide by, in this case, 6. And so 6 plus 1 plus 1 plus 1 plus 2 plus 5, divide by 6, and let's see what we get. Alright, I got 2.6 repeating. Okay, what this tells me, and this is my final answer here, what this tells me is that on average, these data points are all about 2.6 away from the mean. Obviously, some of them are a little further away from the mean, and some of them are a little closer to the mean, but on average, they're about this far away from the mean. This tells me that the data is actually pretty close together because it's not very spread out. Like if the data was way far away from the mean, then this number would be way bigger, which is why this measures spread. So here are those steps, if you want to write those down. Step 1, find the mean. Then, for each data point, basically figure out how far it is from the mean. So basically, subtract the mean and then do absolute value. We call this the absolute deviation. To deviate means like to go away from. So like how far away are these data points from the mean? How much do they deviate? And then you take all those absolute deviations and find the mean of those. So add them up, divide by how many there are. This is a formula for this, and I know it looks complicated, but you could actually understand this pretty well. It's saying, this says take each data point, subtract the mean, find the absolute value of it. This symbol right here means sum. So take the sum of all those numbers and then divide by however many there are. So like average them basically. So you don't have to understand that formula, but it's really not as crazy as it looks. This is on your formula sheet. Again, if that just totally throws you off, don't worry about it. It also describes it in words. So the mean absolute deviation is the sum of the distances between each data value and the mean divided by the number of data values. So basically subtract the mean, take the absolute value. It kind of tells you in the name actually. Go backwards. Find out how much each of them deviates from the mean, take the absolute value, and then find the mean of those. That's why it's called the mean absolute deviation. Just as kind of a visual of this, let's imagine I have the number 3 and then like 6 and 6 and 7 and 8 and 11, 15 and 6. Each of those numbers, this shows how much they deviate from the mean. Like this number deviates quite a bit from the mean, whereas like 8 doesn't deviate very far at all from the mean. And this one deviates pretty far, this one doesn't deviate very far. So we're just taking all those distances and averaging them. All right, just one final example. Go ahead and pause the video and then you can watch me go over it. So again, the first thing I want to do is find the mean. The mean is add them up and divide by 4 in this case. So 3 plus 15 plus 21 plus 13 divided by 4. So 13 is the mean. Now I'm going to find the deviations. So like how far are each of these from 13? If I subtract 13, I get negative 10 and 2 and what's that? 8 and in this case just 0. And then, of course, take the absolute value just to make them all positive. So like this is 10 away from the mean, and this is 2 away from the mean, and this is 8 away from the mean, and this is actually equal to the mean, so it is 0 away from the mean. We'll still include that in our calculations, though. And now just find the average of these. So add up 10 plus 2 plus 8 plus 0 and divide by 4, and I believe that's 3, let's see. No, sorry, 5. So that is the mean absolute deviation. We found the deviations, we took the absolute value, and then we found the mean of them. All right, in the next video we'll talk about standard deviation.